Well, thank you very much, Richard. This is a great honor to be here, and also I'd like to say thank you to Paul Barbara, who will be missed greatly. Okay, to provide a segue from what Richard was talking about, I will also be presenting data on faculty, but these will be at the national level. We've done some research on STEM faculty, and that's what you'll be seeing today. I saw a couple of years ago a publication in that was put out by the Society of Petroleum Engineers, or Society of Petroleum Engineering. In that publication, they talked about a phenomenon they called the Great Crew Change. That refers to the mass exodus of the baby boomers from their scientific workforce and their technology workforce, and the need to hire replacements in a relatively short amount of time. And they were mentioning in this publication, where are we going to find this workforce? They were talking about the lack of U.S. students being educated, their desire to hire from within the U.S., the decline in the interest of the U.S. students in geology, et cetera. And so it made me realize that it's very important what the faculty role is. In order to enter the scientific workforce, the students will need to pass through an educational institution. And the faculty will have a great influence on those students, who is mentored, who has role models, who is encouraged, how do the students feel from their interactions with the faculty. And so it's very important what the characteristics of those faculty are. And so we've looked at the characteristics of those faculty at a national level. We examined 14 different disciplines. We surveyed the department chairs in 100 departments of each of those disciplines. And so today I'm going to show you data on the top 50 of those departments. These, and also for those of you who understand surveys, we obtained the populations, which means that the data are really reliable, even in instances where the head counts are small or zero. And so we've done these surveys 3 times, 2002, 2005, 2007, and so it's possible to look at a snapshot in time, and I will show you one slide that shows a snapshot in time, 2007, and then I'll show you several slides that show the change in the representation from 2002, 2005, and 2007. So this is what, these are the information that you can get from a snapshot in time. It's possible to compare, to look at the pipeline sources. That uses NSF, BS, and Ph.D. attainment data, which are not ours. Those are data from the NSF. But we compare them to our data. And it's possible by looking at that comparison to tell whether or not there's sufficient same gender and same race role models. Compare the percentages, say, Hispanics among BS recipients versus among faculty in order to see if the students are finding enough role models and mentors. It's possible to look at the utilization of the hiring pool, because recent PhD recipients would be the hiring pool for assistant professors who are most recently hired. So you can compare those to see the utilization. And you can compare and also group the disciplines by patterns in faculty data and student data. So here's the first slide that shows the situation for just a snapshot in time. And you can see the comparison between BS recipients, Hispanics among BS recipients versus among all professors. And you can see inside the red boxes, there's a factor of 3 different. You can see the decline in one of the disciplines, the decline in BS recipients, and you can see the utilization of the hiring pool. Even though the Hispanics represent a small representation of PhD recipients, they're not being fully utilized in those disciplines that have these blue boxes. And so this shows also the way that we've disaggregated the data. They're fully disaggregated, and even more disaggregated because they're disaggregated by gender and by rank as well. And so here, this shows the change over time. And again, I've looked at Hispanics, and since Richard mentioned math, let's just look at math. You can see math happens to have the worst performance. The increase over time, these are ranked according to the increase over time, with the greatest increase on the right and the lowest increase or the greatest decrease on the left. And so you can see that math actually decreased by greater than 1%. And note the scale, 5%. None of the 14 disciplines have a representation greater than 5%, even though Hispanics in 2007 were 15% of the national population. You can look at white males. White males are decreasing over time. And again, I've ranked these according to the lowest decrease to the greatest decrease, just in order for the best comparison. You can see in math, there's the greatest decrease. And notice the scale here, this is 90%. And so in some cases, the representation is greater than 80%. But it is decreasing. In order for to have women and minorities move in, white males will have to decrease. So who is filling that decrease in math? You might say, well, it's going to be women. If you look at the increase in women, that's 4%. And you just saw that Hispanics are decreasing by greater than 1%. So you might think, well, maybe it's the blacks are increasing, or the Native Americans. And you can see Native Americans also decreased. And note the scale here, less than 0.5%. The greatest population, the greatest representation is still less than 0.5%. You can look at the blacks and you can see, nope, for the blacks, this is my next to last slide. For the blacks, math were about constant. And in the case of Asians, let me go back to that. In the case of Asians, you can see that the math increased by greater than 5%. In some cases, the representation is almost 30%, even though Asians are 5% of the national population. So I think that this gives you a good national perspective, and I'm out of time, so I'd just like to thank my funders.